So first thing we're going to do is I'm going to make a model of 2 times 5. The first number, remember when we did tape diagrams? Okay, the first number is going to tell us how many boxes we need. So let's start off with 2 boxes. And when you do this, leave a little room up the top because we're going to need that space. What number goes inside the box? John? And then what I just want to do when you diagram this, show that the 5 is what's going in, because you're going to need this when you do the next one. And the 2 is showing us how many boxes we needed to make. Okay? So that's now modeling in tape diagram 2 times 5. Following this model, do the same thing for 2 times b, and I'll call somebody up. All right, Ava, since you're the all-star for this for the third quarter, come on up and show this. Just watch your feet here. All right, so how many have that? Okay, great. Here comes a little bit of a leap. How many of you have seen an expression where you have a number outside parentheses and then something going on inside parentheses? All right, here's the question that nobody can answer today. When you see 2 and then parentheses a plus b, what is that 2 signifying? Dabs? You've actually already gone ahead to the next step. Even before we decide how to figure it out, what is that 2 representing? Luke?
The prime number to multiply into the a and b.
You're making it more difficult than it needs to be. They're really heavily going into this in elementary school. So this is probably brand new to you. And then when I tell you, you're going to be like, oh yeah, of course.
I think it represents how many times you're going to multiply a sum.
You're actually leaping forward even before we do that. Murmur.
How many boxes there are?
Getting closer. CJ. It is a coefficient, yes. Not what we're getting at. Last guess here, Emma, and then I'm going to kind of give you a little bit of a head start.
What you're going to put into that?
All right, backtrack for a minute. Suppose that there is no 2 there. Let's just deal with this, a plus b. Model that right now. Draw a tape diagram showing a plus b. I'll help you. A plus B.
Oh.
It's that simple. Okay, that is one set of A plus B. Now look back at this. What is the 2 signifying?
Oh, wait. How many times multiply it? No.
You're fast forwarding at 90 miles an hour. I want you to back up. 2 groups of A plus B. All right? So that kind of leads me to this next question. How many groups of A plus B are in the expression? There's 2. We're going to model it by showing A plus B. That's one set. Here's the second set. That's modeling 2 sets of A plus B. It's the same thing, but keep it in order. And I've written it out. I've lined it up this way for a reason. Ready? Watch and be amazed. How many A's do you have total when you see it this way?
2.
2 A's plus, how many B's do you see?
2.
Congratulations, you just did the distributive property. Look where you started. Look where you started, 2A plus B. Look at where you wound up, 2A plus 2B. That's what the distributive property is. I took the number outside the parentheses and I multiplied it by each term inside the parentheses.
Oh, okay.
Okay, and the reason why we're able to do this and show that this is equivalent to this is because of what we're seeing in the model. Now watch, we're going to prove it. Go to the next page.
Didn't you just do like 2a squared to plus?
No, because you're not multiplying A times A. You're doing a coefficient times a letter and a coefficient times a letter. Okay? All right, we kind of already did this. We did it on the last page. This is done. I'm just going to rewrite the new expression that we created. And once again, it goes here. Here's how we prove it that they are equivalent. I'm not going to, you know what, even don't, close your eyes. Close your eyes. You tell me, without opening your eyes, how do you prove that each expression is equivalent? Dave. How did we prove yesterday that two expressions are equivalent? What can we always do? Becca.
You have to compare the 2 A's and then the 2 B's and find the value of the letter.
Luke.
I could substitute.
Thank you for the S word. We substitute values. Pick a value for A, pick a value for B, and as a matter of fact, I'll even pick them for you because that's our number 7. We're going to substitute 3 for A and 4 for B in each of our expressions. So let's do that. Here's my 2 that's given. A is what? I crossed it out. 3? Can't see it. 3 plus 4?
Yeah.
Plus 4. Now treat it like any PEMDAS expression. What do I do first? A. What do you get? Remember, this is 2 times 7 now. What's 2 times 7? Okay, Ed. 14 for our original expression. Now let's take a look at this. It's 2 times 3 plus 2 times 4. Who goes first? Luke's. What's the result? Bring everybody else down. Who fights next? Lukey.
2 and 4.
Which is? Bring down my survivors. And look at that. Easy peasy, nice and squeezy. The two expressions are equivalent. Okay? I'm going to teach you 2 new terms. I got it. 2 new terms. When you see it with the parentheses, it's called factored form. Everybody say it.
Factored form.
When you evaluate, like we just did, this is now a familiar term. It's called expanded form again, like you did yesterday. Say expanded form. Okay? Only difference is yeah, this can be considered standard form too, but they also use the term factored form, which it'll make more sense when we do lesson 11 tomorrow. That's why I thought it was better to do 12 before we do 11. Because 11 assumes that you know factored form, and I needed to take you there before we could do 12, before we could do 11. All right, let's move forward. So anyway, this is a recap. This expression now, we're going to do another one. 2, and then parentheses 3x plus, what is that, 4y, I believe. Yeah. Factored form or expanded form right now? Just say it.
Factored.
Louder, because I can't hear you on the blog. Thank you. Factored.
5.
Okay, we're going to make a model. How many sets are there of 3x plus 4y?
One.
Mm.
No, two.
There's two. We'll start off by making one set and then another. Now, we're going to cheat a little bit.
Cheating.
Don't do this, but I could do it this way. It takes up a lot of space. There's 3 x's. Don't draw this out just yet. Plus 4 y's, right? And then I would have to make another set of it. We can cheat. We can do a box for 3x, and I do need you to write this, and plus 4y. That's one set. And then a second set is 3x plus 4y. And if I wanted to do it this way again, don't draw this out, but I'll just show it to you visually, just to show you where we're going next. Here's a set, and then in the cheaters version, this is a set, this is a set. Okay, ready? Add up all your x's. Whether you cheated or not, you can count them each as individually, or here, each one is worth 3x. What's your total amount of x's?
6.
Then,
6.
you got 6x. Add up all your y's.
8.
That's distributive property. You're done. You've gone now from factored form to expanded form. And that's all there is to it. Now here comes the shortcut. Because as long as you know the shortcut, it doesn't matter what I put outside the parentheses or inside the parentheses. If you know what to do, you'll always be able to get the expanded form right. So let's go to the next page. We did this. We did it on the last page. It just worked better. I'm going to rewrite the new expression that we had, which was 6x plus 8y. I do need you to do that. Do you see the shortcut?
Yes. Yes.
Anybody want to come up and blog it?
What?
We'll even rehearse it before you come up. If you want to come up and tell the class, I'll put it on pause, and then if you get it right, we'll put you back on again. Theo, you got like a half hand. Yes or no? It's okay. I don't know anything before I teach it anyway. I've got to rehearse it. Come on up. Come on up. I'll coach you through it. All right, we're going to go off air first, and then you'll talk me through it, and then we'll go back on and sound like you're an expert on it. All right. All right, so we got TL, because we can't use last names on the blog site because it's on the web. All right, so this mystery lady we'll call TL is going to explain us the shortcut. Go ahead, TL.
So you take 2 and 3, which equals 6. So like 2 times 3 is 6, and then you have x. So it would be like 2, 3, 6, x, I think. Like
Okay, so you got 2 times 3x, which
2 times
is,
3, 6x.
that's how we get here. That's this expression. Then what?
And then you do 2 times 4, which is 8, and then you have 8y.
2 times 4y is 8y. Give her a round of applause. She's right. I want to give you an opportunity to work a little bit in class. So let me just get through. Here comes the leap. But if you can get this shortcut into your head, the leap will be manageable. Example 3. Look at the rectangle. Before I even start with the rectangle, what do you already know about trying to find area? What times what for the area of a rectangle? Alexa, it's length times width, right? So whatever value we have for length and whatever value with width, we have to multiply it. Even if they don't give you a value, all they're giving us here is algebraic expressions. So all we know, do you agree with me? We need to multiply this times this.
Yes. Yes.
Okay? So, and I'm going to start with the y. It's this times what? Which I need to keep in parentheses. Okay, now I'm giving myself room. It's technically I could put this here, but I need room. I'm going to put it here. Close that door, Jill, please. All right. Let's apply the shortcut and what we learned yesterday about combining like terms. What am I going to do with this y? Luke.
Multiply it by 4 times, you multiply y times 4x, and then y times 5.
You got it. What is y times 4x? This is tricky. Think about what you did when you did it yesterday. Look at it this way. Ready? Watch. This may even make even more sense.
Oh. Do you have
I expanded it to try to help you out.
do you have to substitute?
Don't substitute yet. You just got to give me the algebraic term.
Well, then it would be 4yx.
You got it, but put it in alphabetical
Oh,
order.
4xy.
You got it. 4xy takes care of this multiplication. How about that?
Oh,
That one's actually easier.
yeah.
What do you got, Sam?
5. No.
Let me put the plus sign in for you. All you're evaluating now is y times 5,
5 times what? No.
which is, you have it, how do you say it?
Oh.
You're giving it to me in
5y?
word form. Yes, thank you, 5y. As strange as that looks, it's correct. Because all we're dealing right now is in variables. We don't know the values for x and the values for y. However, and we're not going to do it, if I were to put in an x right now and a y right now, I guarantee you will get an answer here and you'll get an answer here that are both the same. Okay, we're going to do 1 through 2, modeling it, and then I want you to take the shortcut just because of time. So let's model it first. How many sets of x plus y?
3.
Did I skip something?
No? Oh, no, never mind.
Okay, model it. X plus y, and there's 3 sets of it. All right, let's expand it. How many x's, how many y's? 3x plus 3y, that's distributive property. Done. All right, ready? How many sets of 2h plus j?
4.
Okay, let's do it. We'll cheat. We'll do 2h plus j, and we'll do 4 sets of this. Might run out of room, so keep it tight. How many total h's? And don't forget that those h boxes are 2 each. Maddie. 8 h's. How many total g's? Spence. I'll let you do it. I know you're not caught up yet, but do it right here on the board. You got it. Give yourselves a round of applause. You're doing distributive property. That's it. That's all there is to it. It doesn't matter whether what's in those boxes are numbers, variables, letters, slices of cake. It doesn't matter. Okay? If you know what to do, you know what to do. So, I'm going to have you guys pretty much complete the rest of the packet, but you are allowed to take the shortcut. So I think you've seen it. So this is what's going to happen. For most of you, you're going to do 3, 4, 5, you're going to do page 7. And then you can definitely do page 8. My advanced exercises. If you wanted, if anybody wants to try it, you can, because there's only 2 problems, and I think you can do it. But let that be the last thing that you do. Okay? No, you guys are actually going to do it. All right? And then the problem set. Oh, there is a closing. And then the problem set's the last page. Okay?